Hello, my dear students. Today we are going to solve a numerical problem related to the clutch. This is the numerical problem related to the clutch. A single plate clutch, effective on both sides, is required to transmit 25 kilowatt at 3000 rpm. Determine the outer and inner radii of frictional surface if the coefficient of friction is 0.255. The ratio of radii is 1.25 and the maximum pressure is not to exceed 0.1 Newton per mm square. Also determine the axial thrust to be provided by springs. Assume uniform bear theory. So here you can see that the data is given, the power transmitted, that is P is equals to 25 kilowatt, that means 25 into 10 to the power 3 watt, and at a speed 3000 rpm, and the coefficient of friction is given 0.255, and the ratio of radii, that is r1 and r2, so r1 divided by r2, that is equals to 1.25. The maximum pressure is not to exceed, that means P max, that is equals to 0.1 Newton per mm square, and also determine axial thrust. Assume uniform bear theory. So we have to write systematically the given data. This is the given data. All the data is given in the question. N is equals to 2. That it means single plate clutch is effective on both sides. So for the single plate clutch, N is equals to 2, and that means number of pair of contact. Here we have already discussed the P is equals to this, and mu that is coefficient of friction 0.255, and it is the ratio of radii, that is r1 and r1 divided by r2, that is equals to 1.25. So r1 equals to 1.25 of r2. So P max equals to 0.1 Newton per mm square, and we have to determine r1 and r2 and the axial load, and also we have to determine the axial load provided by the springs, the axial thrust provided by the spring. So first of all, we have to calculate the value of r1 and r2. So we know that the value of power transmitted by the clutch P, that is equals to 2 pi nt upon 60. So power transmitted by the clutch, that is equals to P is equals to 2 pi nt upon 60. Now here we can we know that the value of P is given in the question, and we already know that the value of pi equals to 3.14, and value of N, capital N, is equals to 3000 rpm is also given. So if we can calculate, so we can calculate the value of torque transmitted by the clutch by this equation. So now we have to substitute all the values in this equation, and we will have the value of torque transmitted by the clutch. And we also know that the torque transmitted by the clutch T is equals to N mu W R. We have already discussed in the previous lecture. So this is torque transmitted by the clutch. T is equals to N mu W R. And here you already know that the N is equals to number of pair of contact, coefficient mu, coefficient of friction, and W, that is equals to axial load, and R, mean radius. So here we have already calculated value of torque transmitted by the clutch, and the same value is substituted here. So we have to put the value of T in this equation. So now we have the value of T, and that is N is equals to 2. You can see here the given data, and this is also written here that N is equals to 2 and mu is equals to 0.255 also given. Now we have to calculate the value of axial load or axial thrust. So now axial thrust W is equals to 2 pi c r1 minus r2. We know that we have already derived this equation during the derivation. We have derived a derivation of single plate clutch. So we know that the axial load W equals to 2 pi c, that r1 minus r2. So r1, and we have to substitute the value of r1, that is equals to 1.25 of r2 in this equation. So this is 1.25 of R2 minus R2, that is equals to 0.25 of R2. And but we don't know about the value of C is a constant. So but we know that the it is in this case the uniform wear theory, we are considering the uniform wear theory. So according to the uniform wear theory, P maximum into R2, that is minimum radius, equals to C. So this is, from this equation we will have the value of C. So P max, that is equals to 0.1, the 0.1 of R2, 0.1 of R2 equals to C. The value of C equals value of C equals to 0.1 of R2. So we have to substitute this value in this equation. So this is all the equation is in terms of R2, because here uh, you can see this is 1.25 of R2. 1.25 of R2 equals to R1. So 1.25 minus k R2, that is equals to 0.25 of R2. This is 0.25 of R2. 0.25 of R2. And also the value of C, that is equals to 0.1 of R2. So R2 into R2, that is equals to R2 square. And the W equals to something of R2 square. That means we have the value of W in terms of R2. So this value, we have to substitute this value in this equation torque transmitted by the clutch. That means something of R2 square. Now we have to calculate the value of mean radius. The mean radius for uniform wear theory, that is equals to R1 plus R2 by 2. So this is R1 plus R2 by 2. So R1, that is equals to again 1.25 of R2. So substitute here, and this is the 2.25 of R2 divided by 2. So now we have the value of R2, that is equals we will have the value of capital R, that is mean radius, equals to something of R2. So we have to substitute this value here in this equation. So this equation here, the value in terms of R2, W also in terms of R2. So the equation in terms of R2, and we have the value of torque already we have calculated from this equation. So this only one unknown, that is R2. So we can easily calculate the value of R2 from this equation. So now we have to solve all, we have to substitute all the values, and so by solving this problem, we have the value of R2, that is equals to 96 mm. Now you have to solve and also check the value. This is the correct value. You will have the value of R2, that is equals to 96 mm. So substitute the value of R2 in this equation. Here R1, that is equals to 1.25 of R2. So we will have the value of R1. So R1, that is equals to 120 mm. Now we have already calculated W equals to something of R2. Here in this, by this equation, W equals to 2 pi c R1 minus R2, but we have already solved this equation. So we will have the values something of R2. That means we have to substitute the value of R2 in this equation. So R2 into something, that means 0.11, for example. So 0.11 into 96, that is equals to W. So this is the first example 0.11. So what you have to calculate. So after the solving this problem, we will have the value of W, that is equals to 1447. So this is the numerical problem, and you can solve the numerical problem systematically, and you will have the answers of R1, R2 and W. So Thank you.